I'm back. Sorry, it's been a while. I had to write my thesis, and it was absolutely kicking my ass. But it's cool because I passed my defense the other day, so I finished my PhD. It's whatever. But yeah, like I said, so I'm back, ready to go. Let's get some reaction practice going. So I posted this one the other day, just as a slides, and we'll go through it. So if you have this cyclohexene and you have Br2, nothing else, we're just going to assume it's in a non-interacting solvent. What's the product? We have three choices here. So where we have a cis dibromocyclohexane, a trans dibromocyclohexane, and then we just have dibromocyclohexane with no stereochemistry. Which is the right one? All right, let's work through the mechanism to figure it out. In terms of actual reaction mechanism, this is what our reactants look like, where the Br2 is like that. And what happens is this taxes here, which attacks this side, and it's going to kick its electrons up over to its buddy there. And that's what's going to form this bromonium, I think it's called. Bromonium ion, that sounds about right. And you're going to get this, sorry, my cyclohexanes are god awful. You're going to get a structure that looks like this, where it is, you're going to get an intermediate three-membered ring, where these are wedged bonds indicating that they're up. Now they could be down too, because remember, if you flip this over, they'd be dashed. But the point is that they're on the same face. And then if you kind of think of it, think of my little crappy drawing here, if you're looking at it flat, it would be pushed up like this onto the ring. Now, because of that, its friend here, this Br minus, this be a Br plus, he comes in, and he comes in from the bottom because this is sterically hindered. And he comes in here, kicks our electrons up onto here, and we are left with our bromine, where we have our dibromo species, where we get trans 1,2-dibromo cyclohexane. So, like we just proved with our mechanism, this is the right choice here. Choice B, our trans 1,2-dibromocyclohexane. Remember, this A here, it's a dibromocyclohexane, but these are on the same face, which can't happen in this mechanism. And if you're wondering why C is wrong here, because you say, well, this doesn't imply any stereochemistry, it could technically be this. You're right, but it also implies that it could be this too, which is why it's wrong. So that's why you always need to make sure that you're paying attention to your stereochemistry on your exams, on your homeworks, whatever. All right, have fun out there, guys.